Hi, and welcome to this brand new video. In this video, we're going to be learning about how to solve this problem, where basically you need to find the maximum difference between a node and one of its children, or you can just say the children and one of its ancestors, because it's just the absolute value, so it doesn't really matter which direction it's in. And in order to explain this, I'm going to be using a diagram to explain our method here. So the maximum difference is basically the max value minus the min value. So if we start, let's say at this top node here, I'm going to be using the notation of min comma max throughout this diagram. So here, the min's 8, the max is 8. You go down to its child. Here, the minimum is now 3. And here, the maximum is being replaced. You go down here, now it's 1 comma 8. Go down here, now 6 doesn't affect anything, so you just keep it with 3 comma 8. You go back down here, still doesn't affect anything. Here still doesn't affect anything. Continue on this right side, we go down 8 comma 14, and this remains 8 comma 14. So all we did was go down and find the max and min in that specific branch. And if you're in this scenario, then all you need to do is you look at each one of these and you find that maximum difference, which is that max minus min. So here it's 0, here it's 2, here is 6, 6, 7, 5, here it would also be 5, and here it's 5. So now you clearly notice that the maximum is 7. So in this scenario, you would return 7. Another example is that if this node wasn't 3, but for example it was 9, then in this scenario, you would just replace, it would still be 8 comma 9. And then if you go down here, it would be replaced with 1 comma 9, and then you would return 8 in this scenario. It still works because these two values is a child of this ancestor. We're only recursing, we're only using the recursive function with children and ancestors. Like this node and this node's values never interact because they're not children and ancestors, and therefore we know that all max minus mins should apply to that value, to like the condition that must be between a child and an ancestor. So we're going to use this strategy in order to code. So what I'm going to do is I'm going to create a recursive function, and it's going to accept 3 parameters. Obviously the root, but it's also going to accept the max and min at that specific point. So you can see that in this value, we took the max and min from this one, and then we just updated it with the current node. So that's what we're going to do. First, we're just going to say if root equals null, we'll just return max minus min. Because that's basically just saying is that if you go beyond this, you just return this value of 5. It just makes things a lot easier for us later, so we don't have to be like if root dot left is equal to null, but root dot right, it just eliminates that. Then here we can say max is equal to math dot max of max and root dot val. Min is equal to math dot min, of min and root dot val. And this is that part where we did here, where we took these values and we updated it with the current node. And then all we need to do is return math dot max, a recursive of root max min, oh, sorry, not root dot left of max and min, and recursive of root dot right, max and min. And because we already returned max minus min here, that's why this is able to work, because we're just going to go down into that very last nodes. We're going to find the max and min in those areas, and then we're going to return recursive. Because the larger that you don't need to check in these intermediate spots, because if you go down, you're only changing the max and min. And that means you're going to only increase the difference between max and min. You're never going to decrease it going downwards, because only you're doing is increasing that gap between the two numbers. So that's why you don't need to check at this spot max minus min. And then here you just return recursive of root, and then we can just say root.val for both of these, like we did at the beginning here, 8 and 8. If you run the code, you can see that I accepted with the normal test case. We can submit it, and you notice that we get the right answer. So hopefully this video was helpful, and see you in the next video.